Let's take a look at how Stapplet can be used to calculate the lower and upper bounds for a confidence interval for proportion. In Staplets, we're looking at one categorical variable here with a single group. And here we're starting at the default with counts in categories. So for example, that would be like knowing the counts for different candidates in an exit poll. In this case, Angela got 24. Olivia got 36. Angela is reported to be the winner of the election. So I'm going to focus on her votes. Here we can see a bar chart comparing the two. It's reported that Angela won, but you can see she did get a significant lower proportion of the votes. Specifically, she got 40% of the overall vote there out of a sample of 60. And so we want to do inference on this sample. We're going to take a look at one sample Z interval and focus on Angela. Like I said, she was the winner of the election, and I'll just start with a 95% confidence level. So what we're doing is we're drawing a sampling distribution around this 40% using the information of the sample to construct a theoretical distribution. We're keeping the middle 95% of outcomes, and if we wanted to know a critical value Z for that, we would have to go over to a normal distribution. So going back to Stapplet, I would go to normal distributions and use a standardized distribution with the mean of 0 and a standard deviation of 1. Here what I'm doing is I'm looking at the value corresponding to the central 95% of data. So that should be 0.95. So we look at any measurement that is within 1.96 standard deviations of the mean. So the 1.96 is our critical value Z in that situation, and the standard error is calculated this way. So we can do this by hand as well. It's not too bad at all. What I would do is go to the scientific calculator, take 1.96, which is our Z critical value, times the square root of the sample proportion, p hat, which is 0.4, times the complement, 1 minus p hat, which is 0.6, and divide by the value of n. That's a sample size of 60. So I could find my margin of error this way, and then add and subtract it from my point estimate. So if I take my 40% votes for Angela minus this 0.12, I get 0.28, and 40% plus the margin of error 0.12, and I get 52%. So we can compare that all the way back here. 27, about 28% to 52% is my lower and upper bounds. So I can get the same thing there. Increasing accuracy here if I want to get even a little closer to those values. So it's really not difficult to do this by hand. You would need to use that normal distribution to find your critical values for your given confidence level, but it's also real easy to plug in your summary data and do it this way. If you want to use raw data, you can do that. Let's go to raw data here. All I'm going to do is highlight the candidates' names for the votes that were cast and paste those here. I see an issue already, and I'll just click Begin Analysis and show you. So one issue with these is that I have a space in my data, and this is going to cause problems for me because it's looking at a space as a separating value between data. One way to do that is to save, or to get around that, is to save it as a CSV file, and then we'll put commas between them. We could also kind of use different tactics to get this information out of here. For example, one tactic that I use is I will do an if-then statement. So equals if, and then A3 equals Angela, and this is in quotes, Rodriguez. That's my logic. If it's true, let's just change that to Angela. If it's false, Let's change that to Olivia. This is a quick way to do it. I think this should work. There we go. So now we're just using an if-then statement. You can also look at it up here. So if the value of A3 is equal to full name, comma, we're going to insert a just first name. And if not, so if we don't see Angela Rodriguez, we're going to put Olivia there. And then when I fill down, it just fills down the reference with it. So that's a way to convert that down to a single word. There are other tactics as well. Let me copy and paste this in here. Raw data. There we go. And now I have that same 40%, 60%. And from there, I do it the same way. Look at Angela, 95%. So I don't think you really need to use raw data unless it's an extremely large data set where you have qualitative observations there.